We're on problem 66, and it says, what is x squared minus 4x plus 4 divided by x squared minus 3x plus 2 reduced to lowest terms? So they probably want us to factor each of these quadratics and then see if any of the terms cancel out. So let's try to do that. So the numerator, let's see, this seems pretty easy to factor. What two numbers, when I multiply them, equal 4, and when I add them, equal minus 4? Well, it's minus 2, right? Minus 2 is minus 4. Minus 2 squared is plus 4. So this is x minus 2 times x minus 2. And you could test it if you don't believe it. Multiply that out. Divided by, let's see, what two numbers? This looks factorable. They both have to be the same sign, because when you multiply them, you get a positive, right? And they're both going to be negative, because when you add them, you get a negative 3. So let's see, minus 2 and minus 1, right? Minus 2 times minus 1 is positive 2. Minus 2 plus minus 1 is minus 3. So x minus 2 times x minus 1. And then if we assume that x is never equal to 2, because that would make this expression undefined, we cancel that out. You'll learn later that would cause a hole in the graph, because the function's undefined there. And you're left with x minus 2 over x minus 1. And that is choice A. Problem 67. Boy, this is good practice. They give a bunch of it. They say, what is, so this is 60, I'll just write it, 12a cubed minus 20a squared over 16a squared plus 8a reduced to lowest terms. So let's just try to factor out things on the top and the bottom and see what happens. So in the top, in the numerator, let me switch colors. See, both terms are divisible by 4 and a squared. So let's factor out a 4a squared. So we get 4a squared. 12 divided by 4 is a 3. And a cubed divided by a squared is an a, right? So 12a cubed divided by 4a squared is 3a. Minus 20, I mean, I could say plus minus 20, but you get the idea. 20 divided by 4 is 5. And a squared divided by a squared is just a. And if you don't believe this, multiply it out. 4a squared times 3a is 12a cubed. And 4a squared times minus 5 is minus 20a squared. So it works out. We do the denominator. Let's see, both of these are divisible by 8a. So let's factor that out. 8a. 16 divided by 8 is 2. A squared divided by a is a. Right? So 16a squared divided by 8a is 2a. And if you go the other way, 8a times 2a squared is 16a squared. So it all works out. Plus 1. Right? 8a times 1 is 8a. So let's see what we could do here. So this becomes a 1. This becomes a 2. And then a squared divided by a. Divide both of them by a, and you get this becomes a 1, and this becomes just an a. And we're left with a times 3a minus 5 over 2 times 2a plus 1. And let's see, that is, yes, that is choice D. I thought maybe they want us to remultiply this out again, but that is choice D. Problem 68. 68. 68. Oh, this is a good one. I'll just write it. They just want us to multiply something. So they say 7 z squared plus 7z, all of that over 4z plus 8 times z squared minus 4, all of that over z to the third plus 2z squared plus z equals. So you might say, oh my god, I have to multiply all of these things and I have to divide them. But the best thing, I'm guessing, is to just factor these out, and all sorts of things will start canceling out with each other, and it'll turn into a pretty simple problem. So let's see. Both of these terms are divisible by 7z, so let's factor that out. So that top part becomes 7z times 7z squared divided by 7z. You just have a z left, right? If you multiply these, you get 7z squared plus 1, right? If you multiply this out, you get 7z squared plus 7z. The denominator, so let's just multiply, when you multiply fractions, it's just the numerator times the numerator over the denominator times the denominator. So let's just keep, so this is times the numerator. Z squared minus 4, that's a squared minus b squared. So that's z plus 2, a plus b, times z minus 2, a minus b. Right? That's just the pattern when I say all that a's and b's. So that's z plus 2 times z minus 2. Hopefully you can recognize that at this point. And then all of that over, let's see, we can definitely factor out a 4 here. So it's 4 times z plus 2, right? 4z, right? 8 divided by 4 is 2, times, and let's see if we can, we can definitely factor out a z here. So we get times z squared plus 2z plus 1. I think we're almost done. Now we have to factor this. Let me just rewrite everything. So this is equal to 7z times z plus 1 times z plus 2 times z minus 6. All of that over 4 times z plus 2 times z. And what's this? This is z plus 1 squared, right? Z plus 1 times z plus 1. 1 times 1 is 1, and 1 plus 1 is 2. So times z plus 1 times z plus 1. And now's the fun part. We can this is a 1 here, the parentheses. Now we can start canceling out. And we assume that the denominator never equals 0 and all of that. Let's see, this z plus 2 cancels out with this z plus 2. This z plus 1 cancels out with one of these z plus 1s. I'll do the one that's written messier. And let's see, this z cancels out with this z. And what are we left with? Everything simplified to 7 times z minus 6 over 4 times z plus 1. And that is not, oh, you know what, I think now I see z plus, that's z, I wrote a z minus b here. Z plus 2 times z minus 2. All that pattern matching, I made a mistake, right? Z squared minus 4 is z plus 2 times z minus 2. Not z minus b, and I thought that was a 6. So this is z minus 2 right there. So this is z minus 2. And so that is choice A. Sorry about that error. Brain malfunctions all the time. All right, now they want us to do it again. They want us to find the product, okay, of x plus 5 over 3x plus 2 times 2x minus 3 over x minus 5. Frankly, there's not a lot of simplification we can do. We just have to multiply it out. So this is going to be equal to x plus 5 times 2x minus 3. All of that over 3. I'm just multiplying the denominator. I'm multiplying the numerator and then multiplying the denominators. 3x plus 2 times x minus 5. And now we just multiply both binomials. Do it in green. X times 2x, 2x squared. X times minus 3, minus 3x. 5 times 2x, plus 10x. 5 times minus 3, minus 15. Fair enough. Now if you do the denominator, 3x times x is 3x squared. 3x times minus 5, minus 15x. 2 times x, plus 2x. 2 times minus 5, minus 10. And now let's see, we can simplify. We have the numerator is equal to 2x squared minus 3x plus 10x. So that's plus 7x minus 15. All of that over 3x squared. And minus 15x plus 2x. Minus 15 plus 2, it's minus 13x. Minus 13x minus 10. And that is choice D. Choice D. Next problem. Problem 70. Boy, they want us to keep this up. This is good practice. So they write, this is problem 70, x squared plus 8x plus 16 over x plus 3 divided by 2x plus 8 over x squared minus 9. So the first thing you do, when you divide by a fraction, that's the same thing as multiplying by its inverse. So this is equal to x squared plus 8x plus 16 over x plus 3 times the inverse of this. x squared minus 9 over 2x plus 8. Fair enough. Now let's see if we can simplify these a little bit. I'll do that in yellow. So this is, let's see, 4 plus 4 is 8. 4 times 4 is 16. So this we can rewrite as x plus 4 times x plus 4. Let's see. X squared minus 9, that's a squared minus b squared. So this we can rewrite as x plus 3 times x minus 3. Just going with the pattern. We can factor out a 2 here, so we can rewrite this as 2 times x plus 4. We have an x plus 3 there. And of course, when we multiply fractions, we're just multiplying all the numerator over all of the denominator. So it's almost, you can just kind of make this one line. And so the numerator is x plus 4 times x plus 4 times x plus 3 times x minus 3. All of that over x plus 3 times 2 times x plus 4. So now let's do some cancellation. This is the fun part. So we have an x plus 4 and an x plus 4. Cancel them out. X plus 4, x plus 4. We have an x plus 3 and an x plus 3. Cancel them out. X plus 3, x plus 3. And what are we left with? We are left with an x plus 4 times an x minus 3. All of that over a 2. And that is choice C. And I will see you in the next video.